Hello, everybody. I will start my today another live coding session. So today I solve this question, 3 sum. Okay, given an integer array nums, return all the triplet nums I nums j nums k such that indexes are different and yep, sum is equal to 0. Okay. Notice that the solution set must not contain duplicate triplet. Okay, so I cannot include something like 1 to 2 and 2 1 2. Okay, so let me start with the clarification of this question. So as the interface, I'm given an integer array nums, and I will return the list of triplets. Yeah, maybe list of tuples or maybe list of list. Yeah, and each tuple should have 3 integer elements, so I can write it in this way. Yep. Good. So this is the interface, and let me check the constraint. I'd like to check 2 things at this moment. So number of elements first. And also, I'm wondering, each num can be integer. Obviously it is integer, but it can be negative or 0 or positive. I just want to confirm that. Okay, so take a look at the constraint, and I find that length of num is at least 3. So this means that I can have at least 1 triplet. Okay, and for each num is negative or 0 or positive. Yeah. Okay, good. Let me take a look at example. So let's say I'm given 1 negative 2 1 0 2 maybe. In this case, at least I can say 1 minus 1 1 is something I can find whose sum is 0. So I should return 1. Let's solve it for now. This one. But obviously I can't include 1 negative 2 1 because negative 2 1 1 triplet is already included. So yeah, what the statement means by the triplet, duplicate triplet, is so here it says the order of the output and the order of the triplet doesn't matter. Okay, I see. So I can say inside of the triplet, 3 numbers, order doesn't matter. And also, order of the triplet, it doesn't matter too. Yeah. And that says from that, I can say maybe this one is also order 0, so I included. Order doesn't matter, but let me just put it in ascending order. But there's no meaning for that for now. Okay, so this is an example. So let's think of the brute force approach. I think the brute force approach is look at every possible ijk indexes and no, if sum is 0, add the sorted tuple to set and return the set in the end. The key here is that I do the deduplication twice. Firstly, I use the set here So this means, okay, I sort the three numbers in the tuple, so and push it into set. In this way, no tuple pair are duplicated, and also, sorry, what I meant to say is, in this way, I can do the duplication for this and this. Yeah. So none of them are duplicated. Sorry, maybe it doesn't do the double deduplication, just one deduplication. Yep. Oh, no. I mean, also, these are deduplicated. Also, I can say this and this are deduplicated too, because I use set. Okay, so this is a double deduplication. For this one, time complexity should be n cubed, because I have to take a look at each possible triplet indexed pair. Okay, so let me optimize this. What I'm thinking is maybe I can sort the array. Then I get, now I get -2, 0, 1, 1, 2. Yeah. So now what can I do? Maybe I take one number first, then I use the 2 sum here. I don't know. Yeah, maybe if I take -2, my task is to find the sum whose, I mean, pair of numbers whose sum is 2. So I do the 2 pointers here. Yeah. So I use the left pointer and the right pointer. And if the sum is 2, yes, I can say, now I find the triplet with -2 and the 2 pointers numbers. And if the sum is smaller than 2 in this case, I have to, increase the sum. So I move the left pointer rightward. Yeah, I can do that. So it takes, the sorting part takes n log n. And so I can say 2 sort plus 2 pointers. This takes time is n log n plus n times n. N numbers, and I actually upper bound n times n, because when I took -2 and find all the possible triplet, then I don't have to include this -2 into consideration anymore. And so I take 0, and inside of this, I use the 2 pointers to get this pair whose sum is 0. Then once I find it, I don't have to take care of 0 anymore. So I start with here and do the 2 pointers in this range. So n times n is upper bound. Actually, it should be n plus n minus 1 plus n minus 2 plus n minus 3 plus blah, 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 plus 1. And actually, in bigger notation, it should be n squared. So in total, it should be n squared. Okay. Good. So maybe this is good enough. I don't know. Yeah. I actually, to be honest, I solved this question before, and the best time complexity was n squared in my memory. So I'm implement this with, yeah, I mean, n squared solution. Okay. But do I have to actually sort this? I don't know. Maybe I don't have to sort it. Even if I don't sort, I can use n times n time complexity. So if I take 1, I have to find the number whose sum is -1 in this range. And if I take -2, I mean, I can do the typical kind of two-sum approach, use the hash set for scene numbers, and move the single, index here. Yeah. Maybe this one is good enough. So I will go with this. So for this one, no sorting, but I would call it n times two sums. Time complexity should be O of n squared, and space complexity should be O of 1. Yeah. For this one, for sorting, I need O of n because in Python it is a temp sort and it takes O of n extra space. And for 2 pointers doesn't take any, so it should be O of n in total. Okay. That being said, let me go with n times two sums approach. Okay, I start the implementation. Oh, again, I use this idea, what I introduced in the brute force approach. I mean, use sorted, push sorted tuple to return the set. And in the end, return, convert that into the list and return it. Okay, run this as implementation. So this is the first number. So remaining should be this. So my task is to find the I2 and I3 whose sum is this. So okay, so let's say with this example, I is now here and I1 is here, and I move index I from here, and I can say if, I actually don't need this, if nums I1, with me. So here, which means that nums are nums I1 and nums I. So remaining is this. If this is in scene set, yes. So I've found. So in this case, tuple prepared should be the sorted this one. I sorted and then converted it to set. Okay, so I push it into the returned list. Actually set yet. So then I have to append the current nums I, like -2, to the scene set. Yep, this is it. Okay, maybe instead of I1, I make it I0 to make it clear. Yep, I think this is good. So in the end, I return list of read. Okay. Maybe I can rename this read to founds. Okay, now that being said, let me do the dry run. I will go with very simple case like this. So maybe I want one more. So in this case, oh no. Let's do this. And I expect -3, 1, 2 should be returned. Okay. So first 3 bounds is empty set, and n is 4, and scene set is empty set, and first 3. Okay. I0 is here, and I start from here. So until the end. Yeah. And now sum 0 found is negative num size 0, -1, -2, which is -3. No, -3 is not in scene. So I go to line 80 and I add 2 to the scene set. Okay, then I move I, and now sum 0, sum 0 found is this should be false actually, and I will check it. Minus num size 0 is -1, and -1 is -2. So -2 is not in the scene set, so this is not true. I go to line 80 and I append 1 to set. Good, and I move I, and now I got -3. So -1 plus 3 is 2, and 2 is in the set. So now I find sum 0 found. So now I get triplet as 1 and -3 and 2, and sorted, which becomes -3, 1, 2. Yep. Wait, this should be double. Yep. Then founds dot add triplet. Oh yeah, this is added. Okay. I go to line 80 and I add nums I, which is -3 to scene set. Good. And I come back to line 73 and scene set is reset. Okay, now sorry, I0 is moved. Okay, let me move, speed up from here because I covered those lines. Here, I check 2 and 1, so remaining is -3, not in the set. So I move it. Oh no, sorry, 2 is not added, but 1 is added here. Oh, it's been 20 minutes. Okay, Then I made here. Now the remaining should be -2 plus 3 is 1. And actually 1 is here in scene set. So I create a tuple with -3, 1, 2 in the sorted way, but it already in the funds set. Actually, yeah, funds set doesn't change. And now I is end, so I move I0. And here, I begins from here. Actually, I can't find any triplet because thing set begins with an empty set first, and I can't find the remaining number obviously. So that's the end of the iteration. And when I0 comes here, actually this in a for loop has zero step, no step. So that's the end. And I come back to line 84 and return the list of funds, which is -312. Okay, good. This is as expected, so I passed the test case. Okay, now I'm pretty confident in my code, so let me submit. Triplet tuple. Yeah. Time limit exceeded. Obviously, this is quite interesting, edge case. So maybe I can do the deduplication first. Like this. Actually, this doesn't change the time complexity. This takes over time. But as a result, in the worst case, this nums array doesn't change. Number of elements in this nums array doesn't change. So the worst time complexity doesn't change. But in this specific example, like there's so many zeros, this is deduplicated into single element list. So in this case, this speeds up so much. Let me try it. Oh no. Seems like -1, -1, 2 is not included. Why is it? -1, -1, 2. Let me, wait. I think this broke, maybe. Yeah, this broke because -2, -1. Sorry, -1, -1. I need 2 -1s, but if there's 3, it's still needed because in the case 0, 0, 0, I need 3 zeros. But if there's 4 fours, it doesn't. 1 0 is not necessary. So I can say deduplicating nums, deduplicate over 3 frequencies. Maybe 3 plus weeks. Yeah. So like if this is 1, 1, 1, 1, then this becomes 1, 1, 1. But if there is only 3, it doesn't change. If there's only 2, it doesn't change. Something like that. Okay. So I can say So this is a deduplicated count. No, this should be min of these were 3. So with this, mm, 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 mm. Okay, so in this method, I use the counter and I create the, complete counter. I actually don't need this. I just have to pass nums to the counter as the constructor argument, and I create the counter mapping. And for each num in the counter, I deduplicate the count and append, the number, deduplicate the count to the rate and return rate in the end. Okay, so here, let's say I have 2 count, then this should be 2. If this is 3, this should be 3. But if there are 4 numbers actually, because of the mini function, this becomes 3. This is as expected. Okay, let me take a look at the game. Okay, accepted. Great. So let me quickly wrap up. So today I solved the question 3 sums. And in this question, I'm giving an integer array nums, and my task is to find the unique, 3 numbers which have unique indexes and whose element sum is 0. Yeah, and I return the rest of the triplets. So in this question, I use the 2 pointers n times. So I choose the first number. Then for remaining numbers, I use the typical famous 2 sums approach, which is a hash set. Okay, and a small optimization I had to do is to deduplicate the nums array if there are, more than 3 frequency for some number. I don't need 4 or 5 or more elements in the list actually. So deduplicate them and frequency should be 3. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.